In today's video, we are going to discuss important DSA interview questions. I have handpicked some interview questions from GFG and Lead Code. These questions are mostly asked in interviews. So, without any further ado, let's get into the questions. So, the question says that given an array of positive and negative numbers, arrange them such that all negative integers appear before all the positive integers in the array without using any additional data structure like hash table, arrays, etc. It says that we have an array of positive and negative integers and we have to arrange in such an way that all the positive elements are segregated to the right side and all the negative elements are segregated in the left side. And in this example we can see that 12, 11, minus 13, minus 5, this is the input, and the output should be minus 13, minus 5, minus 7, such that all the negative in one side and all the positive in another side. So the naive solution to this approach will be using an extra array of the same size, and we will traverse the array once to get all the negative elements. Let's say minus 1, minus 2, minus 7 and minus 8. We'll store this in the first half of the array and again traverse one more time to the given array and we'll get all the positive elements like say 3, 4 and 6, and hence we'll get our resultant array. So this approach will require order of n time complexity and order of n extra space. Now the interview will ask you to optimize your given array. So the optimized or the efficient solution to this problem will be using two-pointer approach or partition technique. What does this two-pointer approach say? It basically says that we have two indexes I and j. The index I maintains a range of all the negative elements and the index j maintains a range of all the positive elements. So we start traversing the given array from left side and right side simultaneously such that the index I maintains a range of the negative and the index j maintains a range of positive elements. Let's see by this example. We have given this array and we are supposed to increment I till we reach a positive element. Let's say I is we increment I, it's minus 1, and again we will increment I. As soon as we see it's a positive element, we pause our traversal, and again, and at the right side of the array we decrement the value of j such that, or we decrement the value of j till we encounter a negative element. We get 8 over here, it's positive, we again decrement and we find minus 7, it's negative, we'll pause j. So just looking at this situation, we see that all the elements negative behind I contains negative elements and all the elements behind j contains all the positive elements. So we are supposed to swap the array of I and array of j. After swapping, we get here minus 7 and 2. Again, further we increment the value of I till we encounter another positive element. So it's minus 3, we again increment and we encounter 4 which is positive, we pause our traversal. Again simultaneously we decrement the value of j till we encounter another negative element such that j is over here. We found a positive decrement, another positive decrement and another positive negative. And in this situation, we found this is a negative element and we stop our traversal of j. And if we observe carefully that in this situation our value of I has increased is increased than the value of j. So we can say that this is the breaking condition. And if we observe carefully, we see that all the values from the left side of the I is contains negative elements, and all the values right side of the I contains all the positive elements. So our breaking condition of this case will be I is greater than or equal to j. We see that we have -1, -7, -3, 4, 5, 6, 2 and 8, which is our resultant array. And in this case we find all the elements are segregated in such a way that odd elements appear at the left side of the array and the negative elements appear on the left side of the array and the positive elements appear on the right side of the array. Coming back to the efficient approach, we have an input array ARR and integer n, which denotes the size of the array. So in this we have I placed as -1 and j at n, which was like this. I was initially over behind the array and j was in the extended position of the array. So we see that we have this condition do I plus plus till array of I is less than 0. So we had to increment I till we encountered a positive element. Let's say we have an example over here, -1, 3, 4, -2, and we are executing this case. We have I over here and j over here. Okay, so we do I plus plus till we have array of I less than 0. While array of I less than 0, again we see array of I is less than 0, we I plus plus, and we have our I at index 1, and simultaneously we will do j minus minus, we'll do j minus minus till we get an element greater than 0. Is this greater than 0? No, false. We will stop it here. And in this case, which is I is greater than or equal to j? No, which is not. So we are going to next statement, that is swapping the elements. We will swap this with minus, it will 3 and this will become 3. Yeah, so after swapping this with this, we are getting -2 and 3. Again our loop continues and we see that I will increment till we get another negative element. So like we increment I, is array of I less than 0? No, we stop here, and we decrement j till we get a positive element. Yeah, we get a positive element, we decrement. Yep. And in this case we see that I is greater than or equal to j, and so we break the loop. You see, we have a return statement, we have break the loop, and simultaneously we get our resultant array as -1, -2, 4 and 3, which is our result array. So this is what the interviewer asked for getting an existing array without using any extra space. We have segregated the negative elements and positive elements. We used a partition technique and the two-pointer approach theorem. This question was taken from Geeks for Geeks. You can find the link for the question in the description. Please do like, share and subscribe to the channel, as we are going to upload more and more contents, more and more DSA videos regularly. I have made a list of questions from LeetCode and InterviewBit and GFG, and I'm going to solve it daily for you guys. Thank you.